Hey everybody, I'm back. It's April 14th. Hope you guys had a good spring break. Everybody's staying happy and healthy in your families. If you need anything, please feel free to reach out to me on Google Classroom, Google Hangouts, email, whatever it may be. Please remember we're going to kind of try to do things a little bit different now that we're on break for a little bit longer, at least till April 30th. You guys, every day you should take out a brand new sheet of paper, make sure you put the date on it. You'll be sending it to me through the Google Doc that I assign in classwork. So please make sure that you are staying up to date on all of your stuff, copying your notes, and then trying the homework practice problems to see if you actually understand it. I'll be posting the answers to the homework problems the following day. So the answers for 414 will be posted on 415. So that means you do need to have them done by 7 a.m. on April 15th. So you guys, I'll be making sure I put due dates on those. If you do not finish it by then, I can't give you full credit because I'm even giving you the answers to the homework. You would get half credit. So make sure that you are copying the notes, doing the homework, and then submitting that photo through the Google Doc that I send you in classwork on a daily basis. If you guys need anything though, please let me know. All right, so we're gonna kind of jump into the math today. And you guys, we're going to be dealing with sequences for a while. So what is a sequence? It is a pattern of numbers. So again, make sure you write that on your paper. At any time, you can pause this video. Now, sequences are something that you've actually seen for quite a while, probably even since elementary school. A lot of times they were maybe a sequence of shapes, so a pattern of shapes. But we're gonna be doing a pattern of numbers now. So if you see 3, 6, 11, 18, and 27, there has to be a pattern that kind of ties all them together. But we only know the very basic essence of sequences so far. And what we usually do would be figure out the pattern maybe in our head and then just find the next term. So at this point, you can pause it, but see if you can figure out the next number in that sequence. Now, the pattern that you see is probably going to be a lot different than what I'm going to be talking about here in a second. But what a lot of people see is the fact that to jump from 3 to 6, you could add 3. From 6 to 11, you could add 5. 11 to 18, you could add 7. So if we look at the addition, they keep increasing by 2, or the next odd number basically. So what's the next odd number from plus 7 would be plus 9. So if we followed that pattern, it would be add 11, which is 38. So now the thing about that though is it doesn't always have to be plus a number each time. It could be multiply a number, it could be divide, it could be subtract, but you just got to find out the pattern. But that's all that we know so far. What we really want to focus on the fact is notation of a sequence, what that means, and what's really behind a sequence. So you guys, every term in a sequence is labeled by a number. This is the first term, the second term, the third term, the fourth term. So what math people do is they call this a little subscript for which term it is in. So you guys, this is the first term, so we would describe this as A sub 1. And all that means it is the first term of the sequence. This would be A sub 2, the second term of the sequence. A sub 3, the third term. The fourth term would be A subscript, which is the little number in the bottom right-hand corner, 4. This would be A subscript 5 for the fifth term, and 38 was our sixth term. Okay, so now that we understand that each term in the sequence has like a little notation for it, what we weren't really aware of, there's actually an equation behind each sequence. Now this would be the most difficult thing, is to just come up with the equation all by yourself. But the equation has to work when you plug in 1 to give you the first term. When you plug in 2 to give you the second term. Plug 3 into the equation to give you the third term. At this point, you could pause the video and see if you could come up with an equation. And when you plugged in 6, the equation better give you an answer of 38. So again, if you want to figure this out on your own, you could pause it, but I'm going to give you guys the equation right now. The equation behind this sequence would be A sub n. Now, n is our variable, which means it can find any term in the sequence. It could find the second term, it could find the fifth term, it could even find the 47th term of the sequence. But a sub n would equal n squared plus 2. Now, I knew that equation because I set up the equation before I actually set up the sequence. So you guys, I can prove to you that it will work for any of them. Let's just pick this guy right here, the fourth term. If I use this equation and using correct notation, if I wanted to find the fourth term, I would do a sub 4. But all that means is the variable will get replaced with 4. So I have 4 squared plus 2. Well, 4 squared is 16. 16 plus 2 is 18. So if you look at the beginning, a sub 4, which represents the fourth term, equals, you disregard the work and you go for the answer, 18. And the fourth term was 18. So you guys, behind every pattern of numbers, whether you can find it or not, is an equation. And what we're really going to be focusing on is we're going to be giving you the equations today or whatever, so that you can find any term in a sequence. All right. So a lot of kids have asked me in the past is, why do I really need to know that equation? Well, we're going to go past elementary school by just finding the next term possibly throughout these next couple of days. So you guys, we'll just make sure though that we can use the equations first. So here is your first official problem that you want to do in your notes after you've written that stuff down. Please, again, if it goes on the board, write it down on your piece of paper. But number 1, we are going to find the first 5 terms. So I'm just going to put first 5 terms of, and then I'm going to give you the equation for the sequence. A sub n is equal to negative 2n plus 1. So you guys, that is the equation behind the pattern of numbers. And if I want to find the first 5 terms, I simply set up correct notation. Well, the first term is a sub 1. So a sub 1 would equal, well, that n gets replaced with 1, so that n gets replaced with 1, negative 2 times 1 plus 1. So I'm just going to plug 1 into the formula or the equation. A lot of people actually call it the rule for the sequence, is the equation or the rule. Negative 2 times 1 is negative 2, plus 1 is negative 1. Then a sub 2, well, the second term, I just plug 2 into the equation. Negative 2 times 2 plus 1 equals negative 4 plus 1 is negative 3, and then so on and so forth. I would have a sub 3 is equal to negative 2 times 3 plus 1, gives me a final solution of negative 5. A sub 4 is equal to, or the fourth term, is negative 2 times 4 plus 1 is negative 7. And then my last one that I have to find, because it said the first 5 terms, so the first term, second, third, fourth, and the fifth term is negative 2 times 5 plus 1 is equal to negative 9. Now, we would technically be done, but if you really wanted to see this in kind of like sequence or pattern format, you just write them in order. We have the first term, the second term, the third term, the fourth term, and the fifth term. And then you might actually see a pattern in order to find the next term without using the equation. If you really wanted to, you could think, oh, the pattern is, pause if you don't know, minus 2, minus 2, minus 2, minus 2. So in order to find the sixth term, if I wanted to find a sub 6, now I'm not asking you to do that, but if I wanted to, I could minus 2 again and get negative 11, or I could plug 6 into the formula for the sixth term. So that's why formulas are so important. They actually generate the sequence or the pattern of numbers. Now again, you might say, well again, if I can see the pattern is minus 2, why would I need the formula or the rule? Well, it would go to a problem like so. If somebody gave you a pattern of numbers and didn't say find the next term, and they said find the 400th term, you wouldn't want to just keep writing down all the numbers to figure out the 400th term. So the rule would be so important for that. because they might ask you to do something like this. Find a sub 13 for a sub n equals n times the quantity n plus 1. Now, whenever we want to find it, we want to make sure we actually know what we are finding too. Not only can we use the formula, but let's go ahead and actually do that math real quick. So to find a sub 13, all I do is I use the formula and I plug in 13 for the variable n, because n became 13. So that becomes 13 times 13 plus 1, which is 13 times 14, which is 182. Now, if you want to kind of put it back together, you can rewrite a sub 13 the whole way, but this would be my a sub 13 there. This would be my kind of final answer. But what you want to make sure is you want to know what you just found. So by looking at this notation, what you should be able to understand is that the subscript tells you the number the number place it is in, or the term it is in. So this means to math people the 13th term. And that means if you wrote out the sequence, it'd be the 13th number in that pattern, but the 13th term of the sequence is 182. Okay? Again, if you wanted to find some more numbers and kind of go in order, you could see that this would be the 13th number in the sequence. You could plug in 1 for the first term, so on and so forth, but you don't have to. All right, you guys, that kind of is your notes for today. You just need to make sure you write that all down. Again, get a hold of me if you need some extra help. But you guys are going to have 3 homework problems. So your 3 homework problems that you're going to do on the same sheet of paper, and then take a picture and insert it into that Google Doc for classwork. But number 1, you're going to have this sequence: 5, negative 10, 20, negative 40, 80, and you're going to find the next term. So we're just going to be able to find the next term of a sequence. The second example, I'm going to say if a sub n equals 4n minus 7, so I'm going to give you the rule for the sequence. You're going to find the first 6 terms. And please make sure you're using correct notation. And then finally, your last problem or practice problem is if a sub n is equal to n plus 1 over 2. Find a sub 43 and explain what was just found. All right, if you guys can't do any of these problems, go ahead and rewatch the video. Reach out to me on Google Classroom and I'll do my best to help out. Other than that, good to see you again. Hopefully you guys had a good spring break, and it's your boy, Mr. P. See ya.